Hi everyone, hope everyone are keeping safe. Today I'm going to show you a concept with Splunk that is not really widely used. So what I'm talking about is autoscaling. So this is exclusive to AWS. There is a paper based on how to do this with AWS on SplunkConf. I will leave a link to that document. You can actually have a look at that and you'll get a better idea of how or what autoscaling is all about. So, to give you a brief idea of what autoscaling is, it is basically a group of EC2 instances which are logically grouped together and they are managed in such a way that scaling can happen. So basically what it means is, let's say you have a few number of servers and then there is a incident where one server goes down, if let's say there's a CPU usage that is going beyond the threshold, or if let's say there's a network usage that is beyond threshold and you want to split the load. So in concept like that, you can actually use auto scaling. You can read more about what auto scaling is all about on AWS website. It is quite an interesting read. Coming to Splunk, the way we would use auto scaling is, this is a very good concept that we can use on clustering. So the way we can use this is, we can set up auto scaling so that if an indexer goes down in an indexer cluster peer, like a peer that goes down, you can actually get auto scaling to spin up a new instance for you, right? So like how they are shown it on this diagram here. So they have a few instances and they are on an auto scaling group. So every time an instance is down, Splunk the AWS will actually spin up a new instance for you, right? And then AWS will make sure that you can connect it back to the cluster master. The right way of doing this is, you have to use Ansible or Chef or Puppet or whatever automation tool that your organization is using, so that every time an indexer starts up, it gets all the commands and things to match your environment from your automation tool. There is a functionality in AWS itself called user data, which gives you a pretty basic set of options that you can use just to get your instances up and running. So I'm going to give you a short demo on how we can actually spin up your instances and get it to join a cluster, right? So here, as you can see, I already have my cluster master running, right? It's running on a public VPC with a static IP, and it's running as T2 micro. I haven't set up the auto scaling group with the cluster master as part of that, right? The reason is I'm going to create a auto scaling group with only the cluster peers, right? So there are two main components in auto scaling. One is your launch configurations, and your second is your auto scaling groups itself, right? So let's see what launch configuration is all about. So this is where you actually define where you define what have to happen when an instance is launched, right? So if you can, let's start with creating a launch configuration. We can give it any name. So now I have to choose an AMI. Basically what it's asking for is what image I have to spin up. So I don't have the AMI ID with me. So let's pull an AMI here. So all my new instances should, let's say, it should be running Amazon Linux, right? You can obviously choose whatever operating system you want from the list, and then you can select your AMI ID, right? So I can put my AMI, and then I'm selecting that. Instance type is what type of instance that you need. Obviously this is a demo, so I'm going to choose t2.micro. If you, when you're doing it for your prod environment, you have to go through your Splunk validated architecture, or you get in touch with your sales engineer or your professional services, and then you make sure that you choose your instances correctly, right? Because there's a set of rules that you have to follow when you're choosing your instance. Since this is a demo, I'm choosing a T2 micro because it's basically free, and then we are going to delete the instance once it's done anyway. So I don't need a spot instance. So you can read more about what all this is about. One interesting option is your monitoring. So in AWS, if you are very familiar with AWS land, there's everything happens through CloudWatch. Whatever happens in AWS, it gets logged on CloudWatch. So CloudWatch is basically kind of a logging system. There are many logging systems in CloudWatch, like CloudWatch, CloudTrail, things like that. So CloudWatch is how this launch configurations and auto scaling works. So basically, in free tier, you can actually set up CloudWatch. So CloudWatch actually writes every 5 minutes, logs every 5 minutes. You can bring it down to every 1 minute. So that is what they're asking about for detailed monitoring. So basically what they do is the frequency is set to 1 minute, right? So let's say if you are running a super important prod environment, you might have to go for this option. It is not free. Basically, the basic option is free, but that it's available on a 5 minute window. So for us, we are not choosing that one. And then the most important thing that we have to do is we have to set the user data, right? So this is one tool that AWS gives, so that this is like a boot up script where you can actually tell AWS every time auto scaling boot something, it have to run the following script. I wouldn't recommend this for everyone, because it is not as flexible as using your DevOps tools. Like this can be achieved using your Ansible or Puppet or Chef. So this is just a concept, but then it gets the work done, right? So what I'm going to do is I'm going to tell this. I'm going to tell AWS every time when a system starts up, what all script have to run on that, right? So basically what I need to get done is I need to make sure that when the script starts, it have to have enough data so that it gets your Splunk installed. So if we go look at the script, so this is a bin bash. We are doing a wget. We are pulling the Linux version here, and then we are doing a untap, and then we are going to start an accept license, and then we are going to do a seed password so that I don't have to type it in. I'm just going to set it as my password, because anyway I'm going to delete the environment. In prod you have to change this to match your values, and then I'm going to tell AWS that once this is done, this is how you connect to your master cluster master. Okay, so this is my cluster master's private IP. So I define my cluster master's private IP, I tell my rep port, and then I do a restart. So that's pretty much it. Basically, once all these steps are run, hopefully the Spear will connect with your cluster master, right? Other steps are not important in my context. It might be important for yours, because like the one like this, where you can actually tell whether the newly spun up instances need to have a private IP, or whether it should have a public IP. So basically it's asking whether it had to be launched into a public subnet or a private subnet. So basically it's asking whether you have to, when you spin up an instance, you have to spin it up as a private VPC, or you have to do it as a public. For my demo, everything is public. So you have to work with your AWS specialist to find out what works best for your organization. So this is basically the root volume. Depends on how much hard drive it should be having. For me, I'm just going to set it as 10 GB. So you have to set it based on your ingest rate. If you don't know what your ingest rate should be, you should get in touch with your sales engineer or your PS manager and your consultants, and they will assist you with it. Right. Security groups. This is one important option. So the way it works is all your instances by default will only communicate with each other if they belong to the same security group. I'm saying by default, right? So the reason why I specifically said that is because your indexing cluster master and your peers should be on your same security group, right? If it's not on the same security group, you would have to go out of your way, and then you have to create a routing between the security groups to make it to work. So again, find out what is best for you and your organization before choosing how you want to spin it up. So security group, for me, I'm going to select the existing security group. I'm going to put it on default because this is where my cluster master is set as well. So if this is not done, the peers will not be able to reach my cluster master. Now key pair, this is where what key pair I should use. I'm going to choose an existing key pair that I already have, and I acknowledge that I have the pen file. So that is pretty much it. This is your launch configuration. So once I do this, the options are all done. Right, now I can create my launch. So the launch configuration is done. The next option should be your auto-scaling group. So auto-scaling group is where you actually link your launch configuration with your other options, right? So I can give it a random name, my auto-scaling, and then switch there, Splunk launch. I'm going to choose my launch configuration that I defined earlier. I'm going to select the VPC. For me, I'm going to choose my default VPC. Again, work with your AWS guys to find out what VPC works best for you. Right? I'm going to choose that. US East 2, US East 2B. Advanced configuration for Splunk, we don't really need a load balancer in front because our universal forwarders are well equipped to do the load balancing by itself. So we don't attach load balancers onto indexing clusters. You might be able to do that for your search clusters, but again, work with your engagement consultant and make sure that you understand your environment. So for us, we are doing a indexer cluster, so we don't want to do a load balancer. We don't need a health check. So basically we are just sticking to the defaults. And then let's see, so desired capacity. So basically what it's asking is how many instances I need. So my cluster is a so let's see, master node configuration. I have a refactored 3 SF2, right? So I need to have 3 instances at any given time. Minimum I'll just set it to 3, and maximum capacity I can set it to 4. So you can read what all these options is all about. So it gives you a lot of flexibility, and then you can figure out what is best for your organization. Scaling policies, here's an interesting option. So it gives you a metric, right? So in case you want to say you have to start spinning up new instances every time your CPU hits a certain threshold, and it stays there for, let's say, 20 minutes, things like that. And in that case, do you want to spin up new instances? Then you have to you can choose these options. It is not I haven't actually seen people do this for a Splunk deployment, because normally if we have issues, we would rather fix it for CPU and things like that instead of spinning new instances every time. But again, it always depends on your environment, and then it is best that you decide looking at all your parameters and what you're actually trying to achieve. For our demo, I'm not going to do anything optional. I'm just going to stick with the basic auto scaling, so that this option will make sure at any given time 3 indexer clusters are running. Like there will always be 3 peers available, right? So that is it for me. SNS is basically about notification. So AWS, it's a way of AWS telling you that every time when an incident happens, do you need it to be mailed to yourself, right? So that's what SNS is all about. I don't need it. If you need to get notified every time your peer goes down, obviously you should be. You can set up a SNS topic, right? So every time something happens, the email or a notification is sent to you, right? Tags, you can add your tags so that when instances get launched, it will be marked with a tag. Like it will have a tag so that you can actually understand what you're talking, what the instance is all about, right? So that is the tag. I'm not going to set it up for here and then review. I know what I need: desired capacity, minimum capacity, and maximum. I said what is required, and I linked it with my auto scaling, and then that's it. And what it does is once I click on create, it's actually spinning up instances on my US East 2, right? So if I look here, I can actually see instances starting up. All right. So what it's doing is it's setting up the servers, right? It's setting up the servers. It's downloading all the required software. The softwares the ones that we mentioned on the launch configuration. And then once the software is installed, it is going to contact the cluster master. And once the cluster master is contacted, cluster master will you can take it from there. Like you can push your master your deployment, and you apply your cluster bundle and things like that. So this is where one issue comes up, where you don't have entire control over your environment. So if you had so that's why I suggested you have to take a automation tool route, so that we can link everything together. So every time a new instance comes up, you can make sure the cluster bundle is applied, and then if you want to do additional configurations, you can do that as well. But then for this demo, I'm just showing you the basic options of what is required to get the instance up and running. So I'm just going to pause the video for a few seconds, because it's going to take a few minutes to initialize and download the software and get it installed, and then we'll continue once it's done. Alright, so we can see our instances are up and running. The status is good, and now let's go and see what is happening on our indexer cluster. We can see indexes coming up. So there's 2 peers already registered. Now we have 3. So all 3 peers are registered. So this is automatically done. SF and RF is met, right? So it's going to take a bit of time to do the replication, but we know the SFRF is going to be set up properly, right? So now let's I'll give you a demo of what happens when something goes down, right? So everything is done. Cluster master is all up and running, and now let's see what happens when something. So we turn something off, right? So let's quickly turn this off, and then see what happens. Yeah, I stopped two instances here. As I said earlier, it is going to take a bit of time to time for autoscaling group to start up, because the reason is our CloudWatch is set to 5 minutes, right? So the logs get written in 5 minutes, and then there's going to be a 5 minute delay, something less than a 5 minute delay. So if we have a premium subscription, this timing would actually be better. So as you can see, we stopped the instance, right, and then a new instance actually started running, right? So one started coming up, and now again one more started coming. So the next one will be launched as well. Yeah, now we can see the new instances spinning up. Obviously, there is a small delay. That's why I paused in between, because I'm not using the premium CloudWatch option. But then this got kicked up by autoscaling group, right? So it's going to take a bit of time. So like I said earlier, we terminated 2, and then when we check here, we're going to refresh this. So when the new indexes, the new peer comes up, it will be listed here. It's going to take a few minutes for it to get initialized. But once it's done, it gets registered here, right? And then what happens is, once the new peer joins again, your old peer is going to replicate your data to the new peers, and then they will have the data as well, right? So the whole concept is, AWS takes care of your hardware and Splunk takes care of your data, right? So that is what I'm showing it to you. So we're just going to give it a few moments. Yeah, so we have the second peer that joined now. It is waiting for the final peer to join the cluster. Okay, so after a few minutes, both our new indexes peers have joined the cluster back. It's going to take a few minutes for your indexes to do the replication, and then once that is done, the search can complete, and your clustering will be back to your stable state, right? So basically, this is the concept where we tell AWS to manage our infrastructure, and then we tell Splunk to manage our instances, right? A few things that I haven't mentioned here is, you have to make sure that your heavy forwarders or your universal forwarders on premise are aware of this change, right? Because when a new peer spins up, it have to push data to the new IP addresses. This can be done by using a feature that is native to Splunk, where it keeps track of all your cluster peers IP addresses, and it will keep updating your universal forwarder. You can read about that, and then once implemented, every time a new peer spins up, your universal forwarders and your heavy forwarders will obviously know about that. And yeah, that's it. So hope you have got something from this, and you can obviously try it out if you have a AWS free account, and then you can always reach out to me for assistance, and I can try helping you out. Thank you.